Greg, can you hear us?
Yes, perfectly.
Okay, are we good to start? Okay, so I guess as is customary, I will ask. I will ask the first question. Um, I sort of it's a question which I think cuts across a lot of the talks and the challenge of sort of going from sort of understanding of social order and social norms to actual sort of implementation of those behaviors in robots. So the question, I guess, is what do you think the baseline for sensing and actuation capabilities is for a robot to behave the way we want it to socially? And by sensing, I just don't mean the sensors, but I also mean sense making. So the sort of understanding of what's happening around it, and sort of actuation. When I think about a baseline, I'm not thinking about something like Boston Robotics, because nobody's going to spend that much money to build a robot trash can, or sort of. So I'm thinking about, is it easily available in the state of the art? So, Greg, do you want to go first?
Well, this is what keeps me up at night. Um, I mean, we did not want to do a self-balancing two-wheeled robot, but we realized in order to accelerate and decelerate to keep pace with a person, to more or less have the motion dynamics of a person, we had to do that. So I do think that there's probably, if you want robots to interact in the built environment with people walking around, it does help if they have the mobility, they can turn and accelerate and decelerate with a person who'd be walking around with them. I think what you call walking, and that's all a little bit to be determined. But yeah, I think sensor wise, I think, and processing wise, we can do it for a $3,000 robot. It's hard to go below that, because more than half of our cost is compute and cameras and radar. So, but I mean, I think it's attainable. I don't think it has to be $70,000 with four legs. If you want to go out of the built environment and up and down steps and things like that, then sure. But to be out in New York City in a public space, I think you could do it affordably.
Yeah, I was just to follow on there. I guess I always think with robots, it's not a when question, it's a where question. And we robots can work in limited places, and you can see that with Waymo, and New York's a big place. So I think working with Frank and his collaborators, kind of see that the Brooklyn's a different place from Central New York, which is different from the Bronx. So it's a not a when question, but like a where question.
One thing that we should take into account is definitely that, of course, look at the task you need to do. Like, I don't want to go for the robot that does one single task. But again, if the robot has to follow people, like Greg's robot, well, just build them with the capabilities, with the dynamics, with the actuation that allows it to do that. And not much more. We don't need them walking. We don't need them like simulating the gait of people. Design for what you need. Sort of like Occam's razors again.
Yeah, so recently I've been thinking about one research direction that kind of keep me up at night as well, was trying to steal your words. So right now, I was thinking everyone's asking when the robot can have its ChatGPT moment, and most people are trying to incorporate ChatGPT or basically generate foundation models for robot planning. For example, you can tell a robot cook me pasta, and then the robot can came up with the recipe and then cook everything for yourself. But I think that's not what I observe from the data set I work on with Barry. A lot of time when people are talking to the robot in the field, it's specific about interaction. People are not really telling the robot what to do as a goal. It's more from a lower controller level, right? People in the field interacting directly with the robot, they will not say, okay, go somewhere else, go to the tree. Instead, they will just say, go further, come closer, go faster, or go slower. I think there is kind of maybe the next direction of GPT moment or language model, this is my hypothesis, is instead of going at the high level, top level planning, we may be able to incorporate language model or this kind of scene understanding into the control level and maybe have a better interaction from that perspective. But that's just my conjecture.
Okay. I'd like to open the questions to the audience. So, is there anyone that has? Can you just say your name so that Greg can?
Yeah, absolutely. Hi, I'm John Furr. Thank you all for such an interesting series of talks on navigating movement with people. One thing I was curious about when listening to your talks is robots are often seen as having accessibility affordances. So I was wondering if any of you considered people that move differently in your research. For example, I can imagine people using wheelchairs might have to have more room to navigate when getting in and out of elevators. People who have cerebral palsy or use a cane might move differently when trying to push a robot without contact. So I'm wondering if these questions came up for you.
Yeah, for us, they definitely have, and we, in terms of our detection, we're not 100% there to be able to discriminate between some of those use cases you were mentioning, but we have characterized wheelchairs. There's some stuff on our website and our YouTube channel that has quite a bit of people using our robots with wheelchairs where they'll pair them with the wheelchair. Because a lot of time carrying things, it's difficult to reach behind you to put it in the storage for the wheelchair. So we've done that. We've actually characterized for a organization that provides dogs for people with sight impairments. We've characterized dogs and figured out where to be with the dog when a person's also walking with the dog. So yes, absolutely, we think that there's a lot to be done there. Our smart behaviors team is actually focusing on this topic and has been for the last several months. So I would think in the next year or so, we'll probably roll out some of those behaviors that are focused specifically on what you're asking about.
Yeah, just to add on top of that. So when I was doing the deployment in the field in New York City, that was actually one of the questions came up from the people I interviewed. There are people, of course, there are older people who are actually on wheelchair, and there are people who ask me, oh, my brother has autism. Like, how do you plan to roll out your robot if you have a robot while being in the pocket spaces? Do you consider like people like my brother? And I think that's the beauty of the deployment method we use, which is Wizard of Oz, because when we deploy the robots, I see this experiment as it's an experiment for both sides. It's an experiment for the users, but also for the wizards, because I don't have a guideline for my researchers to drive a robot trash can in public spaces. For them, it's also an experiment. So I would say just do what you think fits, and then kind of see what naturally come out of it. If there's older population, of course, you probably drive slower around it and see what works. So maybe early pilots might be a bit roughy, but maybe later, I think you can see a protocol emerge out of it. So as actually a matter of fact, during our deployment, we have to modify our protocol multiple times, just because edge cases came up. Right, there are times the robot, one example which is not particularly, but sometimes the robot got stuck, and then the other robot come and bump it. Sometimes other people talk to my wizard and ask them these kind of questions. So we need to keep updating our protocol, including the things, oh, what do we do around overpopulation? What do we do around people asking these kind of questions? So it's really like an evolving design process. It's, as we all know, design is iterative. So we start with a pretty open approach, which is just try wizarding and see how it fits, and naturally see where that leads to us.
Just to add one small thing, of course, that's also the beauty of doing this kind of studies in a ethnomethodological way. You observe the real scenario, you observe how people behave, and then you can generalize to what's the norms that everybody follows. But then you can go to the special cases, okay? In the case of wheelchair users, do we have to adjust, like, do they adjust some of the social norms? Yeah.
Do we have any more questions in the room?
One thing I would say from our experiences with an organization in the UK, we had several robots that were used by community of people that were aging in place. And also just with some of our customers, our very first customer is now 99 years old and walks around with one of the Gita Minis. They actually have a relationship to robots that's very unique, which is they feel very seen and they make a lot of acquaintances and have a lot of interaction with people. And even some of the users would walk around with the robots when they didn't even need them, because people would come up to them and talk to them and ask them questions about what was going on. And it's almost the reverse experience that we have with other users who don't want that attention of being with a robot, or they don't want that attention, focused on them. That there are some, I think the aging community is also something we're very interested in and in a very close dialogue with because of that. And so it's not one size fits all. It's very interesting. You can't really generalize a lot of the way people accept and interact with robots socially.
I think, there's a kind of issue with a lot of these robots at the beginning. They're just so unusual that you get a lot of kind of, noticing, and it becomes a kind of thing that you'll talk about. And I know with Waymo, it kind of was a curiosity to start off with, and then it can become potentially at least a problem if it's not kind of behaving right. So and then later there might be other things that happen with them. But I think that's the challenge for those of us who are doing research in this space, is to sometimes we're looking at novelty, really, and novelty is important because these things are new, but be careful not to overanalyze novelty and latch onto that, because at some point it will move on from being a novelty to being something else.
If there are no other questions in the room, we had an online question earlier from Francisca Babel. For you initially, but everyone else on the panel can comment. And she's asking, the halting problem also occurs when people interact with each other while walking, driving. So isn't it just a normal phenomenon that now also is to be expected when we interact with robots? Did you observe other issues when deploying the robot at the airport, like children, people with disabilities in a hurry, causing these sorts of problems?
It's, I guess it's the version of it with people is this standoff where you're kind of like this kind of about to go and not go, and one of the kind of, I think the nice things, at least I see that in the driving data I've looked at a lot, is when something goes wrong, you resort to gestures or like talk as a way out of that. So that was a kind of a question I think I had for Greg there, which is like, do you have this thing where there's something kind of goes wrong with the robots, and then people have to resort to other means to try and work out what to do?
Sure. I mean, I'm kind of smiling because when we did our dynamic obstacle avoidance, we did some that came head on. So we asked people to just cross between, but we thought, we should also just ask people to walk dead on, which is where you get that halting phenomenon where two people get entrained where they're going right, left, right, left, right, left, and suddenly they just stop and they'll usually smile or something and say, just why don't you go right or left? And honestly, our robots perform better than people at that. A little bit with the doors too. There were certain door behaviors where once we analyzed the data, we could make the robots more efficient than the people. And our smart behaviors team said, what do we do in this case? Like, do we go ahead and make them better, or do we go ahead and commit to having pedestrian etiquette and have some of those flaws? And frankly, we always just go for the flaws because we try to have them be as most like what a social situation is. So on the halting, I would think you want to reproduce a lot of those behaviors for people to find them acceptable. But yes, things go wrong all the time. Our robots just sit down and make a noise that lets you know that there's been an error, and they just stop moving. In this, it does happen, with the consumer robots, it happens every few kilometers. And with the industrial robots, it happens a little bit less. But yeah, when they fail, and they do fail, you need to have a plan for that.
Mine is more of a follow-up question then. Should we design for fault recovery? Do we have to list all the failures that we expect the robot to encounter and then design accordingly recovery behaviors, for example?
I know from the Waymo case that they have put a lot of work into pulling over when something goes wrong, and of course that's really difficult to do because when something's gone wrong, something's gone wrong, and so it gets very unpredictable, and it's out of scope. So I guess we're all prisoners of the long tail in robot design.
Yeah, I think for me, I have a pretty peculiar halting problem. I think it's a design flaw for my robot because I put the motor wheels in the middle. And so because, New York City is very bumpy, sometimes the caster wheel in the front and back will lift up the motor wheel in the middle, and the robot literally just got stuck there. And sometimes the participants or the users will see the wheels are spinning in the air, and they see it as a moment to rescue the robot. As you can see in the videos, sometimes it's pretty clear the robot got stuck and people can't help. But sometimes it's because this mistake is quite subtle. We did deploy a recover mechanism, as Mattia said, which was to use the other robot, which is still operating, to bump this one, just to push it out of the stuck situation. And then this makes some other people who are the bystanders observing our robot thought they were fighting for trash. So they're I don't know why they're competing for trash, but maybe I should give the one who fought for it. So it's you have this different strategy, different design decisions give you different outcomes that you never imagined. So yeah, I think I would say just be careful with your design and also the protocols in the long run, I would say.
Do we have any more questions online? And do we have any more questions in the room? Oh, there's one.
Thank you. Thanks for the interesting talks. Kind of carrying on what you just said about people interpreting things in different ways. I think maybe Barry in his talk mentioned that sometimes you want to consider these robots as just dumb machines and just as things, not as social beings. But I kind of feel like sometimes people just project that kind of thing anyway. But it seems like we can maybe influence that a little bit with how we design the robots, either their appearance or their movements. But I guess I'm wondering to what extent do you think in your different applications that you can influence whether or not people see these things as objects or subjects, or whether it's completely influenceable through the design or only partially, and is there a goal there, or will people just do that in different ways regardless?
I think this is the old Eliza problem again, isn't it? Right, as old as we've had machines, because people will, of course, impart things to machines, but it doesn't mean that they're not dumb machines. Oh, no, they are dumb machines, but we impart things. The distinction I usually make though is we're quite good at, for example, animals. We might say, "Oh, the dog is thinking." It doesn't mean that it's the same as a human thinking. A judge thinking is different from a dog thinking. Well, we hope so anyway. So I think it's just knowing that people are a bit flexible with their language and not getting too confused about that. And that's why I think Frank was teasing me a little bit with my kind of point where I say all you need is interaction. But I do actually hold this, that sometimes the language bit can confuse you. And I'm much more a fan of let's just see what people do. And then that's an easier way to settle some of these thorny issues.
I think that it's going to be a real problem if you're a humanoid robot company. And I think with the ability to tell a robot, could you please go to the closest outlet? We can do that, and we've been using chat models to navigate with. But the minute you have that kind of interaction with a person, there's a whole lot of expectations, and calibrating the capabilities with the expectations, I think, is fundamental to good human-robot interaction. And I think when you get a human-shaped robot that can also have text chat, then the assumptions are that this thing is going to have the intelligence of a person. And I think that's very difficult. The trash can, I think you assume a different level of intelligence and mobility. And so, but I do think the form factor and the method of interaction is really what's critical there in terms of what people expect.
Yeah, I think I would add on that. I completely agree. So there was, I think Ronnie Brooke, who was the previous MIT CSAIL director, came up with 3 laws for robotics. And I think I remember the first law was the appearance of a robot should deliver or should make clear of its functionality and its capability. And as a trash barrel robot, we intentionally design the robot to look like a trash can to make sure people understand it's collecting trash. Its motion is just moving forward and backward. There's nothing else on top of it. But you can't really stop people from ascribing emotions or feelings towards it. Just like Barry said, the context really matters. So we observed there was one guy who was a lawyer, because I interviewed him, who was like, the robot is agree with me. I was like, what do you mean by the robot is agreeing with you? He said, whenever I asked a question, the robot was nodding. I was like, the robot couldn't nod, it's a barrel. But then later when we look at the footage, the robot was driving towards a very bumpy terrain, and he was asking the question at the same time. So the robot was wobbling back and forth. And he said, oh, the robot agreed with me. And then he talked to everyone around him, said, oh, this robot can agree with you. So sometimes it just really depends on the context, and sometimes you think just can happen unexpectedly. So I agree that your form factor should clearly come with functionality, but also in the meantime, context really matters.
Was there an online question, Irene?
Yes, there was an online question from Julia. I did ask her to be a bit more specific because she's talking about she's asking about are there techniques for modeling, taking into account or considering social interaction. I think you guys covered a number of techniques, but if you'd like to highlight one, maybe that you think is most pertinent for the research that you've been doing, that would be useful for her.
Yeah. I don't think there is a specific technique that, hey, this is the perfect one where you can just inject your social norms or whatever you want to inject in the behavior of the robot. But there are pre-processed, I mean, if we want to call them what they are, it's just pre-processing. You are engineering feature, you are massaging your data so that it looks a bit more informative, and then after that, do whatever model you want, as long as it works fine. But that's my take. I'm really happy to hear other opinion.
I think one of the reasons why I like working in this area so much is it's, what's the quote, like fail harder, right? We keep trying with these robots and they do, sometimes you get glimmers of great things and then sometimes they go wrong in other ways, but there's kind of clearly progress that we're getting, and that's just really, really fun to work in that and see these things where there's just so many different techniques and the chance to bring in other, not just computer science, but other research fields from the humanities and beyond and stuff. I think that's really exciting. So it's just such a fun area to be working in right now.
I think it's still like an ongoing research topic for me because I think there's so many aspects of social, and one of the purpose of us doing this deployment in the field and also across different neighborhoods in New York City is to understand how culture and how other social factors might play in. So I think this is still an ongoing research topic for me. But if I find something, I'll publish it. Yeah.
Amen.
I mean, I think we would all agree that it's very early days having robots not in a warehouse or a caged environment. I mean, aside from vacuums, which are fairly ubiquitous now, robot vacuums, but even those are not really social. I mean, those are in people's houses. I think it's pretty early days to know if there's any kind of standard or preferred method. I also think robots, the mantra still is that they should be doing the jobs people don't want to do. And so it's very hard to be thinking about a kind of robust social interaction with a robot that's doing a job that a person doesn't want to do. So I would say it's very much early days on robots that are doing things with people, or trying to improve the social, cultural quality of the world. Really, because right now they're still all just trying to do the worst jobs. That's kind of the entire industry is focused on doing the worst jobs, so people don't have to do them.
Okay, I think we are just about out of time. So thank you very much, everyone, for staying until the end. Thank you very much, Greg, for joining us remotely. And I'm just going to let Danilo make a sort of brief closing comment.
Very brief, because it's been a long, interesting day. Maybe, first an applause to all the speakers.